Alright, so continuing with our topic of inverse trig functions, these problems are slightly more challenging. We'll do the first one together, and then I encourage you to pause the video, try the other three. What you're doing here is you're basically first taking an inverse function, and then you're taking a regular trig function. So here's what to keep in mind. This right here, since you're taking an inverse trig function, this is going to give you an angle. That's what comes out of inverse trig functions. And then you're going to take that angle and you're going to plug it into tangent, meaning you're going to basically find the tangent of an angle. So your final answer should be something that looks like this. Basically, it should be, tangent of 30 degrees is root 3 over 3, for example. Tangent of 45 is 1. So you should just get a number at the end which represents the tangent of whatever angle has this cosine. So that might seem a little confusing, so here's the best way we could do this. Some of these can be done in a calculator, but depending on what class you're taking, you may have to do these by hand, so I'm going to show you how to do this by hand. So the first step on all of these is we'll draw a triangle with an angle, which we'll call theta. It has to be a right triangle because we're doing right triangle trig. And we need this angle theta because remember we're supposed to be getting an angle out of this right here. We need this angle to have that as its cosine. So if you remember the acronym SOHCAHTOA, cosine is adjacent A over hypotenuse. So that means that this angle theta has an adjacent side of root 26. That's adjacent. So root 26 would be right here because that's adjacent to theta. And then it has an opposite side, or I'm sorry, it has a hypotenuse of 26. So that's right there. Okay, so this is the angle. We now have tangent of this angle that we just found, which is theta. There's theta right there. Remember we said inverse cosine should give us an angle. So our first step was to draw the triangle, and our second step was to fill in the missing sides using that right there. And then the third and final step is to use SOHCAHTOA, depending on what we need. In this case, we need TOA because we're being asked to find tangent. Use SOHCAHTOA to find out what is the tangent of that angle. So let's do that. So TOA is, that's going to be opposite over adjacent. So there's opposite, there's adjacent. So we need to find out what is opposite to this and what is adjacent. We already know that adjacent is root 26 because it's right next to. We don't know the opposite, but we can find it using the Pythagorean theorem. So there's our c squared. So 26 squared equals this squared equals that squared plus, and then we'll call this b because we don't know that, so b squared. 26 squared is 676. Root 26 squared is just 26. And then if we subtract 26 from both sides, we'll get 650 equals b squared. We'll square root both sides, and that means that b is going to be equal to the square root of 650. Okay, now in this case we want an exact value, so we don't want to put that in a calculator. 650 has a perfect square that goes into it. It happens to be 25 times 26. And you could list out the perfect squares 1, 4, 9, 16, and so on, and just test them to see what goes in there. And it ends in 50, so that's how I knew that 25 goes into it. So it's 25 times 26. Another way of saying that is square root of 25 is 5 times root 26. So we'll have 5 root 26 over 26. We'll cancel those, and we just get tangent of theta is equal to 5. So I want to show you now how you can check in your calculator to be sure that you have the right answer. So here's how you can do it. Put in the, see how we started out with inverse cosine of that, so put that in and find what angle that is, and it turns out to be a 78-degree angle. And then take the tangent of that angle. So I'm going to hit second answer. Answer just lit up. I don't know if you can see it at the bottom there, lit up in red. So that way we don't have to round it off. We can get exact answer. And you can see, when I move the screen, you can see that we do get 5. So that's a good way to check. All right, so that's what's nice about these problems. Most trig tests you're going to have a calculator with you, but at least for finding the exact value, it's usually easier to do some of these, or at least set them up by hand. I think even if you can do it with a calculator, it gives you a little bit better understanding to see how it's done by hand. So I recommend that you pause the video and try number 2. Number 3 and 4 are slightly different, but you can probably figure it out from what we've done so far. Alright, so here's our 3 steps. Again, step number 1 is to draw the triangle. So let's draw a right triangle. This time it has a cosecant. So remember, cosecant is the opposite of sine. It's the reciprocal of sine. Sine is opposite over hypotenuse. That means cosecant will be hypotenuse over opposite. So this is going to be the hypotenuse right here, and this is going to be the opposite. So let's draw our theta angle. Opposite to that is 5, and the hypotenuse is 3 root 5. So this right here means take the cosine of, remember this is an angle right here, it's the angle that we just drew. It's that angle right there. So cosine is what? It's adjacent over hypotenuse. We already know that the hypotenuse of that is 3 root 5. Let's find the adjacent side, which is right here. So that's going to be 3 root 5 squared equals, we'll call this b again, equals 5 squared plus b squared. Subtract 5 squared from both sides. So we get b squared equals 3 root 5 squared. 3 squared is 9, and root 5 squared is 5. So 9 times 5 equals 45, minus, and then the 5 squared is 25. So 45 minus 25 is 20. We'll square root both sides, and 20 is the same as 4 times 5. Again, we're looking for a perfect square, and square root of 4 is 2. So 2 root 5, that would be what b is equal to. Let me just clean this up a little so we can see it. So this is equal to 2 root 5 right there. That's our b value. Alright, so now the cosine would just be, we said it's adjacent, which is that, 2 root 5 over hypotenuse. Once again, the root 5's cancel, and we get 2 over 3. And again, you could check that in a calculator. You could put this in. Actually, you know what? You can't put that in because there's no cosecant. So what you would do instead is do 1 over the inverse sine, because 1 over sine is the same as cosecant. So this is how you could check it. Put that in a calculator, and that will give you what this angle is. Take the cosine of that angle, and you should get 0.6 repeating, which is the same as 2/3. All right, number 3 and 4. So this time, let's think about this. This time, this is going to give us a number, and then our final answer here is going to be an angle, because cosine of 0, that's an actual number. So let's use the unit circle. Cosine represents the x-coordinate. So where on the unit circle is the x-coordinate equal to 0? It's equal to 0 here, and it's equal to 0 right there. So the cosine, actually, sorry, that's I'm confusing you there. We're looking for the cosine of the angle 0. So 0 is just right there. Okay, 0 degrees is right at that point. I was confusing you by talking about inverse trig instead. So what is the x-coordinate right there? Well, on the unit circle, x right there is equal to 1. So this is asking what's the inverse cosecant of 1. Okay, and again, let's put that on a let's think about this. Cosecant is the same as sine, or it's the reciprocal of sine. So we could really ask ourselves, if, for example, if cosecant is 2, that means sine would be 1 over 2. In this case, we're being asked to find the angle where cosecant is 1. Well, if cosecant is 1, that means sine is also equal to 1, because the reciprocal of 1 is just 1. So we can actually solve the exact same problem by just taking the inverse sine of 1, because the reciprocal of 1 is the same. So if you were doing this problem instead, if it said inverse cosecant of 2, you could solve that by doing the inverse sine of 1 over 2. Just take the reciprocal. So where is sine? What angle has a sine of 1? Remember, on the unit circle, sine is the y-coordinate, and the y-coordinate is 1 right there at 90 degrees. So there's our answer. Okay, the inverse sine of 1 is equal to 90, and let's check that on the calculator. So we'll do cosine of 0. Cosine of 0, and again we said that should be equal to 1, which it is, and then we want to do inverse sine of 1, or 1 over inverse sine of 1. It will be the same result, and hopefully we're going to get 90 degrees out of this, because that's what we said the answer was, and you can see it is 90, so that's how you can check it. Alright, last one is to find the inverse cosecant of cotan of 3 pi over 4. So let's start by finding 3 pi over 4. Let me just clear all this stuff away so we have more space. So 3 pi over 4, I always like to work in degrees. It's a little bit more intuitive, I should say. So let's change that into degrees with 180 over pi conversion. 4 goes into that 45 times. So this turns out to be 135 degrees. So we're being asked to find this cotan of 135 degrees. Again, we don't know what cotan is on the calculator, so let's change it into tangent. Or we can find this by using tangent. So the reference angle for 135 degrees, 135 is about right here. The reference angle for that would be this angle that takes us down to 180, which is, use a different color for that, that's 45 degrees. So really this is the same as the cotan of 45 degrees except for one thing. All students take calculus. We're in the second quadrant, and cotan and tan are negative there. So we want to find what is cotan of 45 but the negative of that. So here's an easy way to do this. Tangent of 45, from that table that we talked about memorizing, tangent of 45 is 1. Cotan is the reciprocal of tan. So if I flip over 1, I just get 1 again. So this is the same as the inverse cosecant of this number, which is simply negative 1. And we just did this problem on the last one. The last problem that we did over here had the inverse cosecant of negative 1. Let me just move it over so you can see. Actually, I'm sorry, I erased that. But cosine of 0 was 1 also. Cosecant of 0, I'm sorry, was negative 1. So it's almost the same. Cosecant of negative 1. Remember, we can do this by finding the inverse sign, because if I were to flip that negative 1 over, I would still get negative 1. So where is sine negative 1 on the unit circle? Sine, remember, is the y-coordinate. The y-coordinate is negative 1 right down here. Okay, and that is at the value 270 degrees, so that's our answer. The inverse cosecant of negative 1 is the same as the inverse sine of negative 1, which is equal to 270 degrees.